Okay, so here we have age, seems to be quantitative, marital status, categorical, and earned income is quantitative. So we have three variables. These are gone. And we have two quantitative, so it's going to be the mean age of four people in a room is 30. So the way I prefer to do a problem about average is I like to think about the total first. So the total would be, let's pretend they're all 30. The total is 120. If we add a new person to the room who's 55, the new total is 175. So then get your calculator out, do 175 divided by 5, and you get 35. So 35 is your answer there. Histogram, which of the following statements is supported by the histogram? Now, normally, if these were frequencies here, I would have to count these up and see where the middle one is, like how many terms I have. But in this case, it's percentages. This is relative frequencies. So the median is going to be at 50%. So I'm just going to add up the percentages as I go from bar to bar, from left to right. So 4-ish plus 15 is 19. Plus 25 is less than 50. Plus 8, I believe that is more. So yeah, so that's more than, so somewhere in this bar would be where the median would be, because that's where the 50th percentile is. Which of these statements, so it's between 80 and 85, the median jump is that. Boy, those other ones, these didn't make a lot of sense. Office Supply catalog gives a description of bookshelves that includes the following variables. Which of the variables is quantitative and continuous? So continuous. So the number of shelves the bookshelf has, that's a discrete number. You're counting from 1, 2, 3. So that is not continuous. The number of statistics book, again, a count of a number of books is not continuous. It's going to be discrete. The color, that is categorical. The selling price of the bookshelf is, I would think, discrete, because you're going from, even if you go down to cents, you can't get half a cent there, so it's really discrete. The weight can be any weight in between, so weight would be continuous, because you could be 158.79654, as many decimals as you want for weight. Okay, the table below shows the results of the New Hampshire Republican presidential primary. Okay, but that was in 2012. Which of the following lists of graphs are all appropriate ways of presenting the data? So what kind of data is this? So this looks to be categorical data. So box plot, I don't think that's going to work. So bar graph is for sure going to work. I mean, you can make a bar graph of that, but I think that one's out. With pie chart, you have to make sure it adds up to 100%. If you add those up, I think it does. So I would go with C. So different writers have different styles. It's true. One way to quantify the difference is to compare the distributions of word length in their work. Below are parallel dot plots describing the distributions of word lengths for the first 60 words of Henry James, The Turn of the Screw, Harry Potter, and then chapter 1 of your textbook. Okay, so based on the graphs, which one of the following statements must be true? So let's just kind of eliminate as we go here. So the dot plots of James' word length and Starnes' word length are identical. That looks true. The longest word in the distribution of Rowling's word length is shorter than 25% of the words in the James. So the longest word, which is this one, and in Rowling's is shorter than 25%. No, 25% would be this, right? So it's not shorter than the 25% of the words I don't even think that it did that part right. It's definitely not true. I don't think those are true. The range of Rowling's word lengths is smaller than the interquartile range of Starr's word length. So the range of Rowling, so from 0 to 8, which is 8, IQR is from 2 to 6, which is a distance of 4. So the range of Rowling's is smaller. No, it's 8 compared to 4 now. The median word length for Rowling's is longer than either Starr's or James. So this is the median, and that is longer than the median for that one and that one. So that seems right. 75% of the words Rowling's distributions are longer than the median word length of Starr's. No, Starr's is here, median, and 75% would be like these guys. It starts to the left of that, so I don't think that seems true. So it's definitely D. Time it takes people to finish a certain kind of puzzle strongly skewed to the right. Okay, so I like to draw it to think it through. Okay, so the median might be here, but the mean is going to get pulled with the skew, with those potential large outliers. So the mean is going to be larger than the median. Yep, there it is. Skewed left, mean would be smaller. Mrs. Temple had just finished grading a quiz for a class of 26 students and has calculated a measure of center and spread for the scores. While writing the grades on the quizzes, she realized she's made a mistake, and the highest grade should be 10 points higher. Which of the following sets of measurements will he have to recalculate? Okay, she realized the highest grade should be 10 points higher. So she's got all these grades, and maybe the highest grade was 90 or something, but actually it should have been 100. So how is that? What's that going to affect? Well, the mean will definitely need to be recalculated. So mean, okay. Standard deviation is typical deviation from the mean. Would the mean change? If the mean changed, the standard deviation changed because it's typical deviation from the mean. So I think standard deviation would have to change. By the way, we've already eliminated these two. We didn't have mean limit. And then, okay, so median, would the median change? So there's not a, like, let's just pretend there were 5 numbers. Did the middle number change here? Like, just because I changed that big outlier, potential outlier out there? No. Like the median is not going to change, so I don't think it's that one. Interquartile range, so these would be, if we had 5 numbers, that would be the average. Okay. So the interquartile range would be, could change, I think. Ooh, this is a tough one. So interquartile range, if this is the middle of these guys is the average of these two, the average of these two. So I think the interquartile range could change. It might not change, but it could. I lean towards B. I got to check what 8 is. 8 is B. Yeah. I just want to be sure because that was tricky. Interquartile range is resistant, but it's kind of like the median. For which of the following measures will have to be recalculated? So evidently interquartile range you will not have to recalculate. Oh, but there's 26 students. I didn't see that. So 26 students, interquartile range is not going to have to be recalculated. 5 students, you would have to recalculate. That's what I was having trouble with. I was doing 5 students hypothetically, and it actually says 20. If you read the question, it says 26 questions. That was causing my confusion. It helped me thinking through the median, but it did not help me with that one. Median would be the same 2 numbers. It's not going to change with 26. The population of the United States is aging, though less rapidly than in other developed countries. At right is a stem plot, so just residents. So these are percentages. There are three outliers. Alaska has the lowest, so this one is Alaska. Utah has the second lowest, so Utah. And then Florida has the highest, that's Florida. Okay, so what is the interquartile range for the distribution of the 50 states? Oh, so I guess I didn't need to know those. So what is the interquartile range? Okay, so IQR, so we've got, wait, there are, how many of these guys? There are 50 states. So the 25th and 26th term will be the median. Let me see that. So 1, 2, I don't think I have to find the median though, but let's find it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think that's the median actually. So 135, or no, 13.5% is the median. So that's the 25th, oh no, 25th and 26th terms right there. So that means if you split that in the middle, there's 25 terms below the second 5 and 25 terms above the first 5 there. So if there's 25 terms, it's the 13th term that you want. So starting from the front, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's the 13th term. Going from the other side, 13th highest term, 1, 2, 3, 4, 5, 6, 7, 8. So Q1 is 12.4. Q3 is 14.3. And the IQR is going to be 14.3, which is my Q3 minus my 12.4, which should be 1.9. Wow, pretty good question. Just to think it through. I guess you could type that in your calculator, each number if you wanted to, and do one variable statistics, menu 611, if you wanted to. Certainly be okay. The mean birth weight of sample of infants born at a certain hospital in the month of April was 128 ounces, with a standard deviation of 10.2. Which of the following is a correct interpretation of the standard deviation? Okay, so I have to read that again. So 128 was the mean, and standard deviation was 10.2. Correct interpretation. So think of standard deviation as typical deviation from the mean. So all the infants know. I want words like typical deviation from the mean, about half now. The difference between now. Distance, getting closer. The mean weight born as subsequence is likely to be the mean weight of in subsequent months is likely to be within 10.2 of the mean weight in April. All right, so let me think about this again. So standard deviation 10.2, typical deviation from the mean. The difference between the mean weight and the median weight now, about half the difference. So the mean weight born in subsequent months is likely to be within 10.2. Let's see if E is right for 10. I was kind of hoping I would see D is right. Ah, terrible. Okay, so the distance between the mean weight of each infant born in April and the mean weight was on average about 10.2. I don't love the wording of this. I was discounting it because I wanted to say instead of was on average, was typically, usually, I chose this question, I guess, but I didn't look at it carefully, was typically about 10.2 ounces. The distance between the weight of each infant born in April and the mean weight. So the typical deviation from the mean. So I didn't love the wording of this when it said average. Was typically about 10.2, or typical distance from the mean, deviation from the mean. That usually serves you well. I don't think this is AP quality question right there. More CubeSat missions. Okay, so CubeSat is a miniature satellite used for space research that can be easily deployed from a launch vehicle at the International Space Station. More than 1,000 CubeSats have been launched since specifications. The satellites were joined by the Cal Poly in Stanford in 1999. The side-by-side bar graph displays the types of missions undertaken by CubeSats launched in 2017 and 2019. Compare the distributions of mission type for these 2 years. Okay, so there's no one right answer to this, right? So, I mean, clearly in 2017, education was the main purpose. It looks like 60%. In 2019, education was still the most popular, but it went down to 30%. So it changed quite a bit in that time period. The least popular in 2017 was imaging, and I believe, yeah, imaging. The least popular in 2019 was ballast. I think that seems a little bit lower. So let's see what they said for number 11. The most common mission type was imaging. I might have read that wrong. Did I read the chart wrong? Education, imaging. Oh, there's one to the left of this. I didn't see that. Like there's a blank there. Ballast is not there. Communication is that. So the second one, this is imaging, not education. Sorry, I see that there, but I didn't see it on the left. I was just counting like first, second, third, fourth bar. Okay, so know your colors. The percentage of CubeSat for the mission of communications military is fairly similar. For communication, and about 1% for difference for military, 1% for military. The percent of CubeSat missions for the imaging and science decreased from 2017 to 2019, while all other missions increased. That's an interesting observation there. I really like that they mentioned that. Okay, let's look at 12. So make a histogram of this data. So it'd be easier to grade if I had a set bin width here. And if they give you a little more room for the labeling there. So you want to label the axis and so forth. So like in this one, so I'm going to go every, I guess, 13 to 50. So that's like, I guess I'll go by 5. So 10 is where you'd start. 15, 20, 30, 40, and 50. So you'll have to count how many are between 10 and 15. So 1, 2, So this goes up to 2, I guess here, 2, 4, 6, 8, 10. Hopefully that's enough. So this first bar goes up to 2. Between 15 and 20, 1, 2, 3, 4, 5. So includes the left, but not inclusive on the right. So I think it's just these. So 1, 2, 3, 4, 5. So that goes up to 5-ish, right around there. Includes the left, so that's 20. So all the way up to 23. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to go up to about 9-ish. Between 15 and between 25 and 30, I should say. So 25 to 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it goes all the way up to 11. It's a little above where I have my thing there. And then 1, 2, 3, 4, 5, 6, 7, 8. This one goes up to 8. And from 38 to 40 is 2. Nothing from 40 to 45. There's 1 at 50. Technically, I should do this. Actually, you should go to 55 there. But let's go to 60, I guess, but 2 tick marks. Okay, so that definitely looks like an outlier there. Choose it. So we have to scale it. So this is like frequency. It's not relative frequency. This axis, I'm going to write it, would be I guess it's the HAV score. Oops. Okay, if the value 50 was changed to 30, how would the values of the mean and median change? So this one changed to a 30. So the mean would get smaller. 30 is still in the top half of the data here. So it looks like this number and this number would average make the mean. So I don't think that would have any effect. So the median would stay the same. It would not change, I believe. Let's look at 12 answers. It's their drawing. Oh, HAV angle, not score, sorry. You should read carefully. The mean would decrease and the median would remain the same. So that's pretty good. So that was 12, so 13, a couple more. The states differ greatly in the kinds of severe weather that afflict them. The histogram below shows the distribution of average annual property damage caused by tornadoes over the period of 50 years in the United States. Describe important features of the distribution. What does this tell you about the economic burden of tornadoes that is distributed among the states? Okay, so first of all, this is not a bar chart, this is a histogram, so you can talk about shape, that could be important here. So shape is skewed right. We're going to talk about this in context, of course. There might be an outlier up there between 80 and 90. I should tell you about the economic burden. So it looks like, 25, almost 24, about half the states have very little damage, between 0 and 10 million. Then, it's really kind of a mix with the other half of the states. So it just gets progressively kind of more and more damage as you go. There are a few states, about 3 of them, that might be outliers, right? That usually suffer between 80 and 90 million dollars in damage. Variability is from about 0 to about 90 million. The median, that's interesting. So the median is actually somewhere in this bar, right? Because that would be like 24 is there, so 25 and 26 would be somewhere in that bar there. So between 10 and 20 million is the median. When asked for summary statistics, Minitab produced the following output. Okay, so I love it when they give us all this data, right? The 5-member summary, etc. Explain why, using the Minitab output, why do we know it's strongly skewed to the right? Well, let's look at these two numbers, median and the mean. So the mean is way bigger than the median. So we know it's skewed right because that's a property. The mean is bigger than the median. So that would be why. The histogram suggests that there may be outliers. Use the 1.5 IQR rule to say no values meet the criterion for outliers. So the formula for the upper fence, so the upper fence is equal to Q3 plus 1.5 IQRs. So Q3 is 41.63 plus 1.5 times the IQR, which is Q3 minus Q1. So Q3 is 41.63 minus Q1, which is 2.23. So if I do 41.63 plus 1.5 times that IQR, get 100.73. The max is 88, so that's not an outlier, right? So then the lower fence is Q1 minus 1.5. I don't think this formula is on the formula sheet, actually. So Q1 would be 2.23, sorry, minus 1.5. I forgot what our thing was. So 39.4 was our IQR. So then you get your calculator out. So 2.23 minus 1.5 times 39.4. Negative 56 point something. So the smallest is 0. So you're okay. Definitely no outliers in that set. Not even really that close. Okay, last question. So how much oil wells in a given community will ultimately produce crucial information deciding whether to drill more wells? Here are the total estimated estimated total amounts of oil recovered from all 38 wells in this area of Michigan's basin. So there's 38 of these guys. It's important to know. In ascending order, I love it when they do an ascending order for us. They even made the dot plot, so nice. Find the 5-member summary for this data. Okay, so, boy, I mean, you could type this in your calculator. Let's just do this one because we haven't done a calculator one yet. Let's definitely do this one in the calculator. So hit the home key, go to Excel there. So we're going to call this oil. So 335. I'm just going down for some reason. I don't know why. 13. It's fun to watch, isn't it? Uh, 19, 7, 53. I think I'm on track so far. 21, 38, 6, 82, 52. Great. That's good. Hopefully I typed them in right. Let's look at the dot plot and see if it looks similar. So if you click down here to oil, looks, I mean, pretty similar. Sometimes you scale it differently and it looks a little different. So I think we're okay. I don't see any major things that I might have mistyped. It just looks a little different just because of the way it's scrunched up there a little bit. Okay, so find the 5-number summary. So let's just go to a calculator page, not the Scratchpad, menu 611, one last, choose oil. So the 5-number summary is right there. So it's, I'm not going to write it down. So minimum's 3, Q3 is 35, Q1 is 35, 47, 65, and 157. Are there any outliers? So we just did the 1.5 IQR rule, so I'm not going to redo that again. I'm going to do the calculator though. So actually, let's go back to the current page, or 4. If you go Control left arrow, you can change back to that page. If you hit Menu, Plot Type, Box Plot. Are you kidding me? The box plot? One thing that's nice is it tells you this was an outlier. The 157 is an outlier because it's not connected to the 98. So I really like that feature of the calculator. Now, if you're doing this word problem, it says justify your answer here. So you do want to show the work for that, like we did for the previous problem, if that makes sense. But is there? Yes, there is. And again, drawing the dot plot, you're basically just using, you can kind of hover over this and see like the minimum's 3, Q1 is 35, median's 47, Q3 is 65. The last part of the whisker is 98, and then the unconnected outlier is the 157. So the big thing when you do that is make sure to label your axis, like oil there, it needs to be labeled. Scale out your axis evenly, so 20, 40, 60, something like that. You could do 10s if you wanted to. You don't really need a y-axis, I don't think, with box plots, but that's what you need. How can you tell without doing any calculations? The mean of this data is larger than the median. Okay, so look at the shape. I actually prefer, although it does look right skewed, when you're looking for shape, it's better to look at like a histogram or a dot plot. Definitely right skewed. I'm just warning you that box and whiskers are not great for shape. I've used them, but you always feel a little funny about it. Whereas a dot plot or a histogram are great for shape. So you can see it's skewed right. So the mean is definitely larger than the median because it's skewed right. That's a good enough reason, by the way, in stats. And so you can look at the answers there if you need to, the official answers of what they did. Notice I really like what they did here. Don't forget to do that. Not only did they say the title, total oil recovered, but what is the units? In thousands of barrels, right? So very good job there. That's something I might have forgotten if I'd done that. Easy to forget that. You put a title and you go, oh, but I should probably put the units there as well. Okay, hopefully that helped you. I know that's kind of long, but hopefully it was helpful getting ready for the test if you needed that extra go through there.